Hello there, my name is Preslav Mihaylov. I am the head of training and software engineer at Software University. Today we're going to talk about files, directories, and exceptions. We'll see how to work with the file system and how to handle exceptions in basic terms. First we'll cover what file operations are, how can we write and read into a file. Then we'll see how we can work with directories. Afterwards, we'll learn what exceptions are, and finally we'll see how to handle exceptions and, for example, write some kind of message instead. So let us begin. Let's get started, and hopefully you'll learn something pretty cool from this lecture. I'll see you in the next video. So we'll start this lecture by covering the file class and what it can do. First, we'll cover how we input things into a file. You can use read all text, which reads everything at once, and you just get a string of all the text basically. And you can read lines, which will do the same thing, but this time it will return an array of strings instead of one big string. So let us see how this works. We have a class file. Let's say this is log file equals new file of, well, I have to provide a username, name log.txt. Okay, now I have to include using system.io in order to work with files. Next, I cannot create, oh wait, sorry, it's not used this way, I'm mistaking it with something else. So what you can do instead is write directly file.read all lines and all text. Let's start with read all text, and here I'll provide walk.txt. Okay, cool. So now I'll read this into a string input equals to this, and then I'll just write it out on the terminal. Once I do that, it says, well, could not find file, see user something log.txt. So we have to create it basically. Now, in order to do that, I'll right click here, open folder in File Explorer. Now, here is your project. Your programs are built in bin debug or bin released. This depends on this configuration here, although by default they're the same thing as far as I know. Then you have this files exceptions.exe, and here I have to create my file in order to read it. So I write walk.txt, and now I write hello, this is a log file, it has nothing interesting in it. So this is the text I have in a file. I've created it, and now if I run this program, this time I won't get an exception, but I'll read the contents of this file. Now, what we're using here is file.readAllText. The other thing you can do is apply read all lines like this. However, this is now a string array. And now you can't just print it all, you will have to for each it. And you can write for each string line in input, then print line, let's say 0 is this. So this is the counter and this is the line. So the counter I have to create, we start from 1 and we increment at each step. So now if I read all lines, I can write the line numbers at the left if I want to. Notice how I have this line, hello, this is a log file, I have an empty line, and then I have it has nothing interesting in it. With this method, you can, for example, put line numbers to a file, which is pretty cool. So the difference between read all text and read all lines is that read all lines returns an array or a collection, while the read all text returns the string. One remark I want to make here is that when you work with these two methods, you can have problems when you're dealing with big files. The reason is that, let's say you take this one. This reads all the lines at once. Reading all the lines at once and giving it to you in a string means that you're going to use the RAM memory. And if you're trying to read a file which is 10 gigabytes and you have only 4 gigabytes of RAM memory, well, you have a hard time doing that. Instead, we have alternative approaches to read files, but for now, don't bother with them. Okay, this is enough for basic reading a file, but I'll give you a challenge. The challenge I'll give you in this lecture is to learn how to read a file with a stream. So read file stream C#. Search for this. I'll point you to an article exactly how to read text from a file. Let's see what this is. Yeah, so this is a stream reader. Learn how to use this and try to do this thing which we did here without the read all lines approach, but by using a stream reader. Because a stream reader is more efficient than using this, because a stream reader reads a line one by one and discards it. For example, if I have this huge chunk of a file and I have my RAM memory here, so this is RAM and this is file. If I apply read all lines, and this is the content of the file, I will load everything into RAM and you can overflow it. This is with read all files. But if you apply the stream reader approach and you have some lines of text, you would first read the first line, put it here, do something with it, and then discard it. Then you move to the next one, put it here, and then discard it. Then you move to the next one, put it here, and then discard it. And on and on and on. The thing is that by using this approach, now you don't clog your RAM memory with all the text. You just read a file line by line, do something with the line you have at hand, and discard it afterwards. That way you can read and manipulate a whole file which is really large. But if you're working with small files, then this approach works well as well. Okay, so go and research that stream reader I pointed you to. That's your challenge. Of course, also practice with it. Try to implement the thing we did in Visual Studio, but with a stream reader, and I'll wait for you in the next video. The next thing we're going to learn is output operations. How do we output something in a file? We have file.write all text, which is one thing, which essentially you just provide the file name and the text you want to output. The next thing is write all lines, where you provide an array of strings rather than one string, and you write that to a file. Let's see how that works. This is what we had before. Now I'll just write some text. String, this is, string text is equal to this is some input. Now I write file.write all text to output.txt, comma, text. Once I run this program, nothing happens on the terminal. However, if I open my folder of the project, notice how I have this output.txt file. This was just created now. It wasn't there before, and it has the input, it has the text, this is some input. So that's how you can write to a file. Just to show you that even if it doesn't exist, it will be created. I will delete, then try again, and as you can see, here is the file, and here's the same input, output as before. Another approach which works in a similar way is using write all lines. Instead of passing a text here, however, you have to pass an array of strings. So you can write something like line 1, line 2, line 3. Okay, and that's my text after I run it. nothing happens on the terminal, but in our output you have all the lines here. So you can use both of these approaches based on what you need. A challenge I'm going to give you, oh wait, there's also append all text and append all lines, which add additional text. Oh, that's important. Okay, cool. So you have this now, line 1, line 2, and line 3. Imagine now I want to add line 4, line 5, and line 6. If I execute this program again with write all lines, the file will be overwritten. So as you can see, you have only these. Let's revert. After I run it, now I have my old output, which is 1, 2, 3. Now, if you want to append, not overwrite, you can use, instead of write all lines, append all lines. And of course, we have append all text as well, which just writes a string rather than an array of strings. And as you can see now, the previous input which was here wasn't deleted, but the next input is appended to the previous one. Okay, so that's all you need for writing into a file at this point. A challenge I'm going to give you is learn about stream writer. So search for stream writer, understand how it works, and make a simple program with it. For example, I want you to have some text. Let's say as input you have hello there, Michael, how are you? Something like that. And what I want you to do is get this input and output it with line numbers. Now the input is given from the terminal and the output is printed in the file, but you have to provide line numbers. In order to do that, don't use what we just learned, instead use a stream writer. Okay, that's your challenge. I'll see you in the next video. Now, one auxiliary class you need to know is file info. What file info does is it gives you the metadata of a file. In other words, it gives you some information about the file. Not only the text inside or the contents, you can also read the other properties of a file, like what's its name, what permissions it has, what's its directory, how big it is, when it's created, and things like that. So the file info class provides you with properties that give you more information about the file. Let's see how it works. So you have file info. File info is equal to new file info of log.txt. Okay, and now I can just write file info dot creation time, and I can see when this was created. Once I do this, I see that log.txt is created at this time. If I write file info dot directory, I'll see where this file is located. And if I write file info dot, I want to find the creator or something like that. Nah, I won't be able to do it. You can, with .name, you can just read the name of the file. Okay, cool. So now having this, knowing this, I have a challenge for you, and the challenge is take any directory you want and list all the names of the txt files in it. For example, if I have my file explorer and I have this directory, I want you to list these two names on the terminal, but these ones you should skip. Okay, and that's your challenge. Good luck with that, and I'll see you in the next video. Now it's time to solve some problems with what we already know. The first problem is called odd lines. It's pretty straightforward. You're given an input file and you have to write all the odd lines of that file in another file. line number starts from 0, and you have where to check your solution. Okay, cool. So one remark here, if you want to pause this video and attempt it on your own, the files you should use are called input.txt and output.txt. This is the input file from which you read lines, and this is the output file in which you write lines. That's important if you want to test your solution in the judge system, okay? Now, how do we solve this? Well, we can use what we already know. In order to get all the odd lines, we'll need to somehow access the line numbers. And if you apply file.read all text, you just get the text as string, which is not enough. You need the lines. That's why we can use read all lines instead. Now we get an array of strings, lines, and we can write it out. We can write all lines to output.txt, and here we supply the lines. Now beforehand, you will have to filter the old lines here, and you can do it in two ways. One way is to just do a for cycle, use the index of the for cycle in order to get one line or remove another line, and finally print what you have left. The other part is, since we already know how to use link, we can just write lines where, let me include using system.link, lines where we will take the line and the index %2 is equal to 0, well, to 1, because we want the old lines. Now, before we test, I'll have to create the input and the output. I remove this. I create input.txt, and now I copy this text. Okay, cool. Whoa. By the way, here's a challenge for you. Okay, it's not a challenge, it's just a problem when copying from Visual Studio to a text file. Initially, I thought that the problem with this file was that in Notepad, Notepad couldn't interpret the line endings correctly, and I expected Notepad++ to be able to do it, but it's not the case. It was something else. Okay, anyways, you have this input. Now I run my program, nothing appears, but on the output I get all the odd lines. And I'm comparing at the moment. Yeah, they're the same with what's expected. So that's it. You can use this link way of doing things. It's really cool, really fancy. Or you can just do it manually, whatever you prefer. Okay, cool. I paste my solution here, refresh. Something's wrong. Oh wait, I should okay, I should actually just print the output file. That's really stupid. Whatever. Maybe I just paste it like this. This sounds pretty stupid, to be honest, but maybe that's what they expect. Yeah. Anyways, well, you just couldn't use the judge system for this exercise, it seems, but you can obviously compare by hand whether everything is okay. Here you can see the solution. It's not the same as ours, but it's similar. You can study it and see where it differs, and learn some new stuff. Anyways, if you haven't done the problem yet, do it now, and I'll wait for you in the next video. The next problem we're going to solve is line numbers. So you're given some input file, and you have to insert line numbers in front of each of its lines. The result should be written in another text file. I will just use input and output.txt again. Now, we actually already did this while I showed you some of the how to work with what we just learned. So, you already know how to do this. Don't wait for me to solve the solution, attempt it on your own. Okay then. Now, what's the catch here? We read all the lines, then we make a for cycle, starting with 1, and going to wait. We start from 1, right? Yeah, 1 is dot length, but we use less than or equal, and then we just, what do we do? Well, lines of I is equal to lines of I and the I thing and the index. So maybe this will work. I'm not entirely sure, and let's test. Write all lines output.txt, and then we write the lines. So I run this, index out of range. Oops, sorry. This is because I start from 1. Maybe I can start from 0, and the index will be I plus 1. Okay, this time it worked, and let's see if we got the correct result. And yep, now every line has a line number. Maybe I can try testing here. Well, I'm not sure what. Maybe I should supply this text. Okay, I can just copy this one. Of course, this is not solving the problem, but oh wait, 0 points. So there are 5. I'm not sure what they expect here. So they expect plain text. Then I really don't know what they expect here. Anyways, from for the fatal of these two souls. Okay, cool. I'll just grab it here. Oh. So this is our text. I put it in my input.txt. Again, we don't have new lines. I should put them manually now. Okay, cool. Now when I run my program, in output.txt we get all the lines. However, they expect one more line, which I have no idea why they expect it, but I'll just paste it here. Now when I copy and I paste my text here, I get 0 points again. Oh, okay, so they expect not a colon but a dot. Changing that, of course, you have to modify the solution as well. But this is a pretty bad way of checking a problem, to be honest. Okay, cool. I have no idea where this text comes from. I can try submitting my solution, but I'm not sure whether it will work. And I would expect it not to work, as we can see. Anyways, this task is a bit broken. Don't mind that. Just, solve it, test locally, and that's it. Anyways, that's it for this task. Do it yourself if you haven't already, and I'll wait for you in the next video. The next problem we will solve is called word count. You're given a list of words, and you have to count how many times those words are found inside a given text file. In the end, you should output in a third text file. The frequency is ordered in descending order. And that's the whole task. Pause this video now and attempt it on your own. Okay, cool. Let me guide you through it now. Well, first we have to read our input, which is the words, and it said that the words will be in a file called file. Let me just read all text words.txt. Now once I read it, I want to first lower it, because in the problem description we are given that the matching should be case insensitive. Okay, that's the thing we want to cover here. In order to do that, we should make our files lowercase. Apart from lowering them, I will split them because it's given on one line, and that's how I get the words. Let me show you what this file is. I already created it. It's this one. Afterwards, you have to read a text file. We will read it in a similar manner. File.read all text, but the text will be input.txt. Again, lowering it in order to apply case insensitive search, and then splitting. But this time the split will be a bit more dramatic, because notice how in this text there are many words, and the separation between those words aren't just white spaces. You have commas, dashes, dots, question marks, exclamation marks, hyphens, all those stuff. So we have to enumerate them all. I have to write split by a white space, but also split by an exclamation mark, a question mark, a dot, a hyphen, and some special symbol. Well, I can just enumerate all the special symbols, but I won't get it. If you want to make it really properly, you should split by all the special symbols there are, but for the sake of this task, I don't need to do it. Okay, cool. So that's my text. Now let's see what we have in our text. We have string, word, and text. Oh, by the way, this is search words, the words we're going to search for. Now, for the words in the text, we will just output them. Okay, so these are all our words. It seems that I missed one character, which is the comma. So I'll add it here. Apart from that, you might notice that there are many empty entries. Now, you probably know why this happens already. It's because when you split by multiple separators, sometimes you can get these empty entries. In order to remove them, you can apply the string split options, remove empty entries. However, for this task, that won't be necessary, because those empty entries, well, what we have to do is we have to check every word if it matches the words we're searching for. And the empty entries won't match them, therefore we don't have to worry about that. Okay, cool. So I'm not going to remove the empty entries, but if they bother you, you can remove them as you please. Now, we have to count the word frequencies. Well, in order to do that, we can use something we already learned in a previous lecture, which is a dictionary. So we start with a string and an int. This is word frequencies, and this is a new dictionary, blah blah. Okay, apart from that, before we get to solving it, we have to initialize the frequencies of the words we have to 0, because if we have, let's say, quick and let's say work, once you encounter them in the text, you will increment the counters against them. But there might be a third word, which is it, and it occurs 0 times, but you also have to output it. However, if we never add it to the dictionary, we won't have that info. We will just see the quick and work info. What I mean is, if I just write here if word, Well, search words dot contains. I'll use a bit of link here. If some of these words contain the word I have currently, then I write word frequencies of word plus plus. Before I write that, I have to write if word frequencies dot has key, well, contains key of word. If it doesn't contain it, then assign it to 0. However, if I use this approach, in the end, in this dictionary here, we won't have all the words in some cases. If there is a word which doesn't, if it's given in this text file, but it's not encountered in the text, we will never initialize this. We will never write that the frequencies of these words are zeros at the first hand. That is why, before we start anything, we have to go through all the search words and initialize them to 0. That way we don't use this check, and we're sure that all the words will be included in the dictionary, even if they would have a 0 frequency. So that's it. In the end, if I enumerate my entries in the word frequencies, entry dot value, well, I can add it like this. So 0, 1, entry dot key and entry dot value. As you know, this actually is a key value pair. It's a string and an int. Basically, this is normally you can imagine the dictionary as a list of key value pairs, because you have keys and values, and when you are for eaching a dictionary, you will get as an element a key value pair, which contains the key and the value. And once I have that, as you can see, I output all the words. However, what is left to be done, by the way, this is correct, but what is left to be done is to order these words. So, in order to do this, I'll apply some link again, and I'll write word frequencies dot order by descending, since they have to be in descending order, entry, order them by the value. Finally, cast it to a list, and I'll get a list of key value pair ordered frequencies equals this. I iterate that and everything should be fine. What I just did was, let me write it out like this. I get my dictionary, I order by descending by the value of the entry, and finally I turn it to a list. When I turn it into a list, I get a list of key value pairs. Finally, I for each it and I print out everything. Now we have the same output as is expected. All that's left to do is write it in a file. In order to write it in a file, one thing you can do is you can append all these things in a string array, and finally do file.write all lines into a text file. A slightly easier approach I would suggest is using a stream writer. What a stream writer does is it writes to a file line by line. That way you don't have to collect all the lines into some array or a list and finally push them into a file, but you can do it on the go, on the fly. So this is a new stream writer. I will write in the results.txt file. In the end, I have to not forget closing it, although if you don't do that, it's fine. And finally, I just write streamwriter.write line of these entries. And that's all my task. Now, if I run this, notice that I have a results.txt with the output. If I delete it and I run my program again, I would still have it. And by the way, for this task, if you want to pass the judge assignment, you will have to just submit the output. and you get 100 points. But the important part was implementing the algorithm. Here you have a similar approach. You can look at it as well. Although it's not complete, it's pretty similar to what I have. Okay, if you haven't done this problem, do it now, and I'll wait for you in the next video. Now, apart from working with files, we sometimes have to work with directories as well. That's why we have a directory class in C#, which is very self-explanatory. It has operations create directory, which obviously creates a directory, delete an empty directory, move, get files, and get directories. And now we will go through all these. Now, this is what I have currently. What I'll do is I'll create a new directory by writing directory dot create directory temp. Once I do that, notice how I have a temp directory. Now I want to move all these 3 files to the temp directory. What I do is directory.move, I don't need this anymore, input.txt to temp. But I have to do this for all the 3 files. Input.txt, results.txt, and words.txt. Once I do this, cannot create a file when that file already exists. Okay, maybe I messed something up. Moves a file or a directory to a new folder, new location. Okay, maybe I'll just write temp/input.txt like this. This time it works. And if I go to my directory, notice that I don't have the files anymore, but they're in the subdirectory. Now I'll show you how to read the directory. You can write directory.get files of temp. This is a string array, files, and I'll just print them. File and files, print the current file. Once I do this, you get all the files I have in that directory. Apart from files, you can have subdirectories, which I'll create now. Subdirectory 1 and subdirectory 2. Okay, cool. Now I can write directory.get directories. Once I do that, I get all the subdirectories instead. What else is there to show you? Well, you can delete a directory, get the files, get directories. Now for the delete thing, that's all which is left to show you. It won't work if you don't have an empty directory. Once I do this, the directory is not empty. Now, in order to override this, I should add the true parameter here, which is for recursive. Now, probably you have encountered recursion if you have read a bit more apart from these lectures, but basically what it means is you should not only delete the directory, but recursively delete everything inside it. That means you should delete the directory, the things in that directory, the things in those directories, and etc, etc. In other words, you delete the whole file system tree which that directory has. And now once I run this time it was successful, but everything's gone. I delete the folder and all the files inside of it. Okay, so that's about the directory class. It's very self-explanatory, nothing really that hard here, and I'm sure you can start using it just now. See you in the next video. Now we will solve a problem using directories for getting the folder size. So you're given a folder named test folder, and I should get the size of all files in that folder which are not directories. Print the result on the console in megabytes. Okay then. So I have to get the directory, but first I have to create it, of course. I'll name it test directory and I should have some files inside. So I'll create a new file called temp.txt and I'll just flood it with some words. Like this. Okay, it should be big enough now. So the size of this file is that many bytes. It's not really that much. I can actually add a bit more. Yep, this should be enough now. Okay, that many kilobytes. Maybe if I add something really big, I will make it even bigger. So I'll just go to my desktop, I'll get this lovely picture here and I'll put it inside my folder. Well, not the desktop itself, that would be bad, but this picture. Okay, so this is a picture drawn by my roommate of a tree. It's really fancy. Anyways, it's 752 kilobytes long. That should be enough. So now I get the files in my directory, get files in test directory. Okay. Now I have to calculate the size of all those files. So this is a string of files, file names. I have to for each of those file names and for each of them I will calculate the length by using the file info class. File info of, well, new file info of the file name, file info.length. Okay, that's what I need, and now I have to accumulate it in size equal to 0, size plus equals this, and in the end print it. Okay, now this didn't work. Cannot implicitly convert long to int. I should use long then. Running it now and I get this number. This is actually bytes. In order to convert it to kilobytes, I divide it by 1024. Then I get the kilobytes. Oh, by the way, I should apply double division if I want to get the correct result. Then I divide again by the same thing in order to get the megabytes, and it turns out that the files are big, that many megabytes, 0.738 something, which corresponds to what our Windows says. It's 752 kilobytes here and a bit more here. It's not exactly that much, but it's something really close. It's that the difference there in calculations is related in how you sum it. But as you can see here, just applying division by 1024 is sufficient. Anyways, that's the size of all the files inside our folder. And that's our task. Here's another solution. In this one, the only difference is that in the end, they don't print it on the terminal, but they output it in a file instead. Anyways, that's it for this task. Play with it a bit, try it yourself, and I'll wait for you in the next video. The next thing we're going to cover is exceptions. Now we're moving away from files and talking about something auxiliary, which you should know as well, and that's exceptions. Now, exceptions is a way to handle and raise errors in a very nice centralized way. The way exceptions work is the following. So let's say you have some methods. Foo, bar. Now you have the foo method, which calls bar. Then you have the method foo bar. And at this point, you get an exception. Now what an exception does is it stops execution of the current method, this one, and moves on to the top one. When it moves to the top method, if there is no handling of that exception there, it will go to the top one. And this continues until it gets to the main method, which, if it doesn't handle the exception, the program crashes. What I mean is this. Let's say I just write throw new exception, something bad happened. Once I do this, I get an unhandled exception that something bad happened. If I do it in a method, static void foo, and I throw it here, invoke foo from here, I still get the exception. The difference is that this time there is a stack trace. What the stack trace is this, these two parts. So using this information, you can trace where this exception occurred. For example, this thing here says this occurred at line 12, while this one occurred at line 17. So this is a stack. It means that first the exception happened here, and then it fell back to the bottom part. So notice that this is line 17 and this is line 12. That's where it says it first started here, but it then continued here. If you have more methods, let's say you have static void bar, and you have exceptions here, this time you have 3 stack traces, starting at the main method, this is the foo method, and this is the bar method. So that's what an exception does. It cascades and fallbacks through all the methods you have. And they're very helpful in the fact that whenever something bad happens, you just throw an error, and independent of whoever is using you, he will catch the error. He will receive it. For example, imagine it in the following way. It's like there's a boss of your boss. So you have this big guy here who's the CEO. So this is the CEO. Then he has his subordinate. Let's say that's his I don't know, VP of engineering, VP. Then you have your, I don't know, team lead. So you have your team lead, and then you have you. Now, imagine that while you're doing your work, something bad happens. So you're doing something here, but finally you get some kind of error. Now when that error happens, you tell your boss and you say, hey, some exception occurred. I tried to write this file, but it didn't happen. If that problem is not resolved with your team leader, he will cascade it to the VP of engineering, and he'll have to say what to do. If you don't know what to do and your team leader doesn't know what to do, then the VP should know what to do. Maybe the VP doesn't know what to do, therefore he cascades this to the CEO. And the CEO is the one in the most charge, and he should be able to decide what's going on here and how to solve this problem. But if he isn't able to solve this problem as well, then your company crashes, you go bankrupt, or I don't know, you just stop living or something like that. At least that doesn't something that happens in real companies, but that's something which happens in your programs. If no one handles this exception, the program will just crash, leaving you with information about how that exception happened. And there are many exceptions. If you have an exception, if you get a hold of it, I'll actually show a bit later how you can use it to extract some info and not crash your program. Which is the next part. The next part is talking about how we handle those exceptions. How do we stop the cascading of that error message at your team leader if he knows how to handle whatever is you're troubling you? So that's the next part we're talking about, how to handle exceptions. Now for your research, what I want you to do is write exceptions in C#. And let me find you a nice, well, perhaps a nice thing explaining it. Well, this is not good enough. Let's see, exceptions.NET Purls. Maybe this is good enough. In the .NET Purls, read this article. And it also covers something we'll talk about in the next video as well. Anyways, I'll see you in the next video. Now we'll see how we actually handle those exceptions. We saw how to raise some errors, but now it's time to see how do we handle them at some point. The way you do it is by using the try-catch statement. Imagine that here at bar an exception happens, but here at foo you can handle it by writing try this and catch whatever's a problem, catch exception E. So you can write E dot whatever you want. Here you can extract messages from your exception, for example the message. Once I run this program, something bad happened, but this time the program didn't crash. Notice what happens this time. I run my debugger. Now I am at the bar method. I go inside, and now I get to the point where I throw an exception. When I leave bar, I go to the catch block. This is what happens when an exception occurred. And here you have some handling code, for example, how to handle that exception. In our case, it's just printing a message, but it can be something else as well. And if that exception doesn't happen, if instead you have just a normal message, this is bar here. If I run my program with the debugger, I go inside this method here, I print this is bar, and once I go out of there, this catch block is not executed. It's only executed when an exception is handled. And by using the try catch block, you can handle those exceptions. So that's how you can stop the error spreading in your organization at your team leader. If your team leader knows how to solve your exception, he will do it. Only if he doesn't, he will cascade that to his person in charge, his boss. Anyways, that's the simple part of exception. So you have throw new exception with some message, and in the catch statement you can catch it. Here you can inspect whatever you want. For example, you can get the stack trace. If I print that, I'll just, well, I don't see anything because there's no exception, but once I throw it, I only see the stack trace, which is where that exception happened. Maybe you want that for login purposes or something like that. And you have other things as well. We won't go through all of them, but I just want to show you that you have plenty of info you might want from an exception. So now we've just covered the exception, but there are others as well. And exceptions differ in terms of severity. There are some exceptions which you can handle, and there are some which you can't. For example, imagine that in this method here, I write in.parse of console.readline. So here I print a.message, and I print an exception happened. So once I try to read something from the terminal, if it's incorrect, I get an exception happened and the error message. But this exception was not a normal exception. It was actually a format exception. If I don't catch it, if this is not here, removed like this, or I just invoke bar here, then you would normally get the system.format exception. Okay, This happens when you've input an invalid number or something which your compiler doesn't understand. Those kinds of errors you can handle with the catch statement. And you can explicitly catch the format exception, but you can also write the exception. So one thing you gotta understand here is that exceptions in C# have hierarchy. At the top, you have the exception class. Beneath it, you have other classes as well. For example, somewhere along the lines, you have the format exception. You might have something else, something like, I can't think of an exception. Anyway, some other exception. So you have these hierarchies here, and based on what you're catching, you will catch all the subsets of that exception. For example, if I write catch a format exception, I will only handle this. I won't handle the rest. For example, here, if I write catch a format exception, and I write an invalid number, that exception will be handled. But if I invoke a different exception as well, a different exception instead, something like, I don't know, this one, yeah. This is an argument no exception. Now, an argument no exception is different than a format exception. However, I only specified the format exception for me to handle. I didn't specify the argument no exception, and I can catch that as well. Argument no exception. I can handle it in a different way. This is a no exception, while this is a format exception. So notice now, if I write Ctrl-Z, which means I'm not inputting anything, I get this is a no exception. So I got into the argument no exception catch block. But if I write an invalid number instead, I get a format exception. And there are many kinds of exceptions. Some of them you want to handle, like these ones. These exceptions which we're seeing are ones which normally can be handled easily. I mean, it's okay to handle them. But there are exceptions which you shouldn't handle. For example, such exceptions are exceptions like, well, there's an error with your hard disk. When there's an error with your hard disk, maybe it's out of scope for your program to solve it. You should leave it to the operating system and just crash the program, because that's a serious issue. You might lose some data or something else might happen, which is not okay in any case. So be careful about that. And as I said, if you have the format exception, you handle the format exception, you will handle only that. If you have the argument no exception, and you catch that, you handle only that. But if you handle the exception, that's the root of all the exceptions, you will handle everything possible they can throw at you. For example, if I write catch any exception, a generic exception occurred. If I write, come on, okay, I should remove these ones now. So if I write an invalid number, I get caught. That exception is caught. But if I write an empty input, that exception is also caught. Previously, one of the exceptions wasn't caught and the other was caught. And that depends on which exception you're handling. If you're handling a more lower level exception like this ones, some other exceptions might not be handled. But if you're handling a more top level exceptions like the root of all exceptions, the exception class, you will handle everything. However, a good rule of thumb is to never write this. Never catch this, because this will handle any exception. And any exception means that you can handle a wrong number from the terminal, format exception or something like that, but you can also handle a bad sector in your hard disk, which is something which you shouldn't handle. Maybe you run out of memory, maybe something else happens. If you're doing this, you have a serious issue of neglecting some serious problems which might occur, and you won't even see them, which will in the end result in a blue screen of death. If you don't know what a blue screen of death is, maybe I'll just remind you, it's this one's. Well, this is some video, but it's this one. This a blue screen of death means that something bad happened and your computer couldn't handle it. This can occur if your programs catch all the exceptions like this. That's why I suggest you, when you're writing such code, catch only the exceptions which you need, not all of them. Okay, that's the basic version of try catch. Here you can catch a specific exception, or you can catch all of them. You also have a finally statement. Now, what the finally statement is something which will always occur, no matter whether you succeed at catching an exception or not, and no matter whether the exception is caught or not. So let me show you. In finally, I print this will always be printed. So if I input a valid number, this will always be printed, appears. So when there is no exception, you will execute the finally block. If there is an exception, you will also execute the finally block. And if there's an uncatched exception, it will also execute the finally block. This means that this block will be executed in any case, whether you succeeded, whether you failed, or whether you caught an exception. So why do you need this? Well, you need this when you want something to happen at all costs at the end of the operation. Imagine the following thing. So you have your program, but you have a file as well, which you are reading line by line. So this is your file. And imagine that currently you're reading this line and something bad happens. If you just crash your program like that, the file could remain open. And afterwards, if someone tries to read your file after, let's say, your PC restarts, he will see some issue saying that the file is already open or there's something else. So you would want to, whatever the circumstances, you would want to always close this file. And the way you will do that is by using a finally block. Because no matter whether you caught an exception or not, no matter where an error occurred, no matter anything, in the end you always want to clean up your mess by closing the files which you've opened before. So that's an example where you would use the finally block. And without that much practice, I would say it's a bit hard to understand the use cases of it. I know this is a bit more theoretical, but with practice you get a hang of it. For now, you should understand how it works, and it works in the way that this block will always execute, no matter whether you have an exception or not, and no matter whether you caught the exception or not. You have some other variants. You can have the try catch and finally block. You can have the try finally block, and that's it. That's all the three things you need: try, catch, and finally. In the try block, you write your code which you want to execute. You want to try executing. In the catch block, you write your code for handling a potential exception, and in the finally block, you write what you want to happen after these two operations at any cost, no matter whether an exception happened or not. So that's it for handling exceptions. It's not complex. It takes a little time to master it, and I'm sure you feel proficient in it soon. Anyways, that's it for now. You will do some handling and raising exceptions in the exercises where you will understand this concept even better. I'll see you in the next video. So now it's time for our summary. We just completed the files, directories, and exceptions lecture. What we learned today was how to use the file class to create, modify, and delete files. We use the file info class in order to inspect some metadata of a file. We saw the directory class with which we can inspect directories and manipulate them in some way. And finally, we talked about exceptions, where we learned how to raise exceptions with the throw keyword and how to handle them with try, catch, and finally. And that's it for this lecture. I'll wait for you in the next lecture where we will learn a bit more about string operations. For now, go to your exercises, do them, and get proficient in files, exceptions, directories, and all that stuff. I'll see you on the exercises.